I have a problem. You see, I live in a city called Vancouver in Canada, and my grandma, she lives in a city called Penticton. It's around 4 hours drive, 400 kilometers from where I live. But I promised my grandma that I'm gonna always, every week, go and see her. But you see, the problem is, it takes 102 hours to walk from where I live to where my grandma lives. So I didn't know what to do. It's impossible to actually walk there and come back in a week and do it again. So I asked Alex. Alex is a friend of mine. She always helps me with all the questions I have. So I asked her, Alex, what can I do? She said, Sohail, why don't you buy a car? Just use a car. That will solve your problem. I was like, I didn't think about that. So I bought a car. It was sitting in a driveway. And I was like, how is it going to solve my problem? So I asked her, Alex, it did not solve my problem. She said, Sohail, you got to drive the car. You got to use it. You got to drive it and go to your grandma. Problem solved. So I started using it. You know, it takes around 4.5 hours to 5 hours drive every time that I go and meet my grandma. But as soon as I started doing that, I realized I'm terrible at navigation. So one time, I just got lost. It took me 12 hours to get to grandma. One time, it took me around 8 hours. Different reasons. So I didn't know what to do. So I went to Alex. I said, Alex, I have a problem. Still, it's not solved. Still 12 hours too much. She said, why don't you use the navigation apps? Google Navigation, Apple Navigation, or all other navigation apps. They are there for you to actually not get lost. So I started using that. It solved a lot of problems. Now, I was never lost. I started getting there sometimes 4 hours, sometimes 8 hours, sometimes 6 hours. You know why? Because of traffic. Vancouver has so much traffic. One day, it took me 6 hours. I was in traffic. So I knew who to go to ask. I went to Alex. I said, what now? What can I do now? She said, why don't you take a look at all the past times that you went to grandma? See which time is the best time to give you the optimum point, the least amount of traffic. Look at the data, look at the past data, and analyze it. I was like, yeah, that helps. So I started doing that. So now I knew which dates and which time I have to leave, so I have least amount of traffic. That was great. So instead of having 12 hours, I was driving 4 hours to 6 hours, 5.5. It was consistent, but not that much, because sometimes I was tired. And when I was tired, I was driving slow. When I was happy, I was driving fast. And then one time, I got pulled over. I got a ticket. One time, I got into an accident. So, I guess at this time of story, you know I'm not the smartest person. I went to Alex again. I said, Alex, what to do now? She said, maybe it's time for you to upgrade the car. Maybe it's time to actually use a car that has new technologies, like assisted driving, like adaptive cruise control, all other technology. It helps you to stabilize and decrease the time. I started doing that. So now I knew what time to leave. I knew what navigation and route to take, and I knew and I had the adaptive cruise control, and I was not getting into accidents. So started to see my grandma 4 hours to 4 hours and a half every time consistently. But you know, now I'm bored of driving. I want to do other stuff. My time is too valuable. I want to do more important things. I want to browse TikTok. I want to look at Instagram. So I went to Alex. Alex, what can I do? And she said, it's time for autonomous car or hire a driver, one of those. That is too expensive, so maybe I should wait for autonomous car. But it got me wonder. From 102 hours that it took me to walk, I brought it all the way down to 4 hours consistently. Instead of the variations, all that, all gone with using technology one step at a time. And now I want to just get rid of that 4 hours to make it autonomous. Isn't it exactly what we do in mining, in mineral processing, in our process industries? There is a journey for making things autonomous. Look, let's not lose the focus on that 102 hours, bringing it all the way down to 4 hours. There's so much value there. And you might ask how? Well, there are 5 steps of autonomy that we can help step by step walk through a mineral processing plant. So let's look at them. Step 0 or level 0. This is actually, a lot of people think that when they have a process control system, they're actually level 1 or level 2. But the reality is that we see a lot of plants, they have process control system and everything is actually operated still manually through the process control system. So we actually call this level 0. You still have invested in the car, invested in the infrastructure, but you're not using it. You're not driving the car. You're still running things manually. And then when you go to level 1, let's look at SAG mill, for example. Level 1 is when you have some PID controllers to control the weight, control the feed, control the speed. Often we see that operators use these PID controllers, and when the variability of the ore starts, they immediately take the automation off. They can do better. And you know what? They are right. They can do better because the PID controller is not the answer for everything. And that's the level 1 of autonomy. Level 2 is when we have the advanced process control to deal with all the variabilities that comes with the ore variability. In the SAG mill, for example, control the entire area with the multivariable controllers. Level 3 is when we actually bring instrumentation, additional instrumentation, virtual instrumentation into the mix. So for example, we have SAG mill feel or angle of impact, all calculated, integrated into the advanced process control, make everything automated. Level 4, we call it fault tolerant, when we monitor the condition. And then that's where if the pumps or something goes wrong, instead of the operator to intervene, the optimization algorithms can intervene. And level 5, fully autonomous. Now, is this a dream? Actually not, because typical mineral processing plants are around level 1 to level 2 when we go and look at them. And then what we have done in a lot of different areas in the world is bringing process industries, mineral processing operations into near level 3 to level 4 autonomy. This is not a dream anymore. We talked about that decreasing the hours down, decreasing the variability down. What is the actual value there? So let's look. This is a consolidated results of implementation for 156 applications for the last 10 years in 42 different sites around the world. A step-by-step implementation of technology, addition on top of each other. That's how we can unpack all the value. So let's look at the first step, which is basically decreasing the variability down as much as possible. That's where we call it level 2 autonomy. So we have model predictive controllers and advanced process control to actually bring the variability down, push for more production. We see somewhere around 4 to 8% of increase of production, saving a lot of energy and also a lot of reagents. Then we go to the level 3, which is actually adding additional instrumentations that are specialized instrumentation for example, PSD measurements, or looking at the Mills charge, or the ball charge, or angle of impact. These are the measurements that we either can have physical instrumentation for, or we can actually use virtual instrumentation, use digital twin technologies. And after that, we go to the level 4 of autonomy, and level 5 sometimes. And that is when we have plant-wide coordination, or for the specific applications, use machine learning, use the AI. Yes, this is the first time in my talk I talked about AI and machine learning. It doesn't mean that we don't have those technologies. It means that they have to be used at the right place so that it brings the value, fit for purpose, to actually answer a specific problem. So when we want to move toward the autonomous operation, this is not just about AI, it's about the whole entire life cycle of the technologies, the instrumentation, the control software, the plant operation, the actuator, so many different, the turnkey automation solutions, so many different technologies have to come together to build an autonomous operation. This is not just about bring the AI in and solve all your problems. Now, you hear that I started talking about AI. Doesn't mean that we don't have those technologies. It just means that it has to be practical at the right problem. So let's talk about AI a little bit. I will, in this talk, actually will show you some applications of artificial intelligence that we actually implemented with the results. But let's talk about what is artificial intelligence. Oftentimes, a lot of our customers ask us this question. So a lot of times we tell them, and this is what we believe truly, is that AI is where the perception of us about technology changes from understanding of that technology to black magic. This line is where the AI happens. Think about it. 40 years ago, AI was what-if analysis. AI was the PLC programming. AI was the ladder logic. Now, AI is reinforcement learning algorithms, is generative AI, is all the other fancy words that we don't have any perception of how they work. Deep learning, neural network. But really, to some of the audiences, they know exactly what those algorithms are. So, AI is basically a bunch of statistical algorithms that actually is able to do a task. That's what it is. Now, what if I tell you there's a secret to that? There's a secret to the machine learning that you hear about it. Which pill would you take? Would you take the Andritz Blue to know the reality? Or you don't want to know? I'm assuming if you're listening and looking at this and watching this, you want to take the blue pill. So you know what? Let's ask the AI what that secret is. Let's call ChatGPT. Hey ChatGPT, what is the dark secret of artificial intelligence? Let's see what it says. So of course, as an AI language model, it cannot tell us all the secrets, but here's the important part. AI algorithms are only good as the data that they're trained on. And if the data is biased, the resulting AI will be biased. Think about it. A lot of these machine learning algorithms require vast amount of data that needs to be correct, needs to mean something. Now that's where our case comes. You don't necessarily need to have a fancy ML algorithm to solve all your problems, because it comes with its own problems and limitations. Now, in Andritz, we solved this problem because exactly the reason for that is we won the Disrupt Mining Competition Award. That's where Gold Corp at 2019 asked all the companies to come up with some disruptive technologies. And Andritz proudly won this award for $1 million because we foreseen this problem of AI being biased on data. How do we solve that problem? with the digital twin technology that we have developed for the last 25 years. And that's what made us the winner of this competition, because this is how we train artificial intelligence. So there are a lot of technologies that Xandr is bringing to walk one by one to autonomous operation. But as I said, this is not machine learning, and AI is not the answer for everything. So where do we use the AI? We use it when the environment is too complex, when sensing is too complex, or the decision making is too complex. Not everywhere. It has to fit for the purpose. There's so many conventional good algorithms that are already bringing value. So why not use them? So, we thought about how can we make it simple for you. So in order to understand what algorithm to use, we have to understand the problem first. And we brought all Andritz engineers, 2,000 different engineers from different aspects and science background. We brought them all together and asked them, come crunch the numbers and come up with one simple guideline of how to use, when to use machine learning algorithms. And we made it happen for you. It's not that hard. Can we use conventional algorithms to solve the problem? If the answer is yes, then just use the established algorithms. If the answer is no, then think about the new technologies or machine learning. Because there's a lot of value to what we have. There's a lot of money on the table. Now, you heard about a lot of AI that I talked about in the last couple of minutes. Let's put our money where our mouth is. Let's see if we actually have done actual projects that brought value, tangible value. Remember, we said about fit for purpose. The problem we are not able to solve the problem in a conventional way. One of those scenarios is the screening shuttle. So this is a problem in Australia for a big mining operation. We're not going to name this operation, but you actually can see some of the papers that the client has actually published. Now, the problem is, it might sound simple, and that is, there's a fast-moving shuttle cart and the whole entire screening that requires the ore distribution. And this shuttle car goes through these silos and then drops the ore. First of all, how can I make this operation more efficient? And then second, there's this specific problem. Sometimes it happens that the silos get overfilled. So then you can't dump any ore. That specific silo goes out of commission. Now that shuttle has to jump. Imagine if there are 5 silos and the silo number 3 is overfilled. Now you have to go silo 1, 2, and then 4 and 5. What happens is, because this shuttle goes very fast and there's a big time delay for the ore to come, then the operators, there's no algorithm can help us to if then else algorithm or conventional algorithm can help us to actually jump that bin. The operators cannot do that either because the shuttle goes very fast. So the operation ends up to stop the bin 4 and 5, losing immediately 40% of the production. That's a huge problem. Thousands of codes in the PLC has written over and over revisions and never was able to solve the problem. That's when the client came to Andritz. Andritz, can you solve this problem? We said yes, but it's not going to be one easy solution. It's going to be a combination of different solutions. And this is where you see that level by level increase of technology. You see, we brought advanced process control to very much stabilize the operation of all the feeders and the bins. to stabilize that, decrease the variability as much as possible. You can see that we decreased that process variability by around 4%. The bin starvation decreased by 17%. Throughput during the normal operation increased by 5%. And then we were able to tackle the next problem, the shuttle problem. And that's when we used other technologies. We actually used reinforcement learning algorithms to train AI about the environment so that it can make decisions how to jump the shuttle. And that's where we increase the throughput by 40%, then the breakage happens. The gradual increase of technology with the actual value. Is that the only example? No. Let's look at the autonomous tailing. That's another problem that we face in our mining that cannot be solved with the conventional methods. Let's look at the problem. The problem here is that when you have a filter press operation, if the operator usually looks at the filter press, and filter press has either runs or washes or changes the class or goes on the idle. The operator looks at the operation and then looks at the maintenance time, looks at the time that the filter has run, the availability of the water for washing, the efficiency of the filter, and make a decision. Is it a good time to wash or not? Now, this is an easy problem to solve manually when you have 1 or 2 filter presses. But then, when it becomes 8 filter presses, 10 filter presses, this problem of when is the right time to wash, to change class, to run, to go idle, the combinations becomes a huge problem. We did a little bit of the math. It's around 7 million different scenarios that can happen in this situation. And if you want to automate these scenarios based on the conventional methods, you need something around 1 million lines of codes to actually solve this problem. So, how can we solve this problem? Operators today, they run everything based off time because there is no other way to actually handle this. So a lot of filters go run under efficient. A lot of filters, we change the class when we don't need to because it's everything on running by time. And if the variability in the upstream happens, that variability goes into the filtration. How can we make it autonomous? Think about it. Look at this is an interesting concept that we actually got it from the gaming industry, video gaming industry. All of us have played video games. So for example, you play these shooting games that you see all these characters, 20, 30 characters. They run at you, they duck, they shoot at you, they hide. And you would think, how is this possible? How is that possible that these creatures in the video game know what to do, each of them, based on the actions that you make? But it happens, there is actually an AI technology or algorithm called utility AI that allows the video game industry to actually make this happen, make it as if they have the intelligence. So what we did in Andritz, we said, why don't we use the same technology to do the exact same thing for filter presses? So now we brought that technology, an algorithm, on each of the filter presses, and then made each filter press to understand the surrounding of itself and understand when to run, when to wash, when to go to the idle. Now, each filter press starts to talk to each other based on what is happening on upstreams and what is happening on downstreams. So now if you have 7, 4, 5, 10, 20 filter press, it doesn't matter because each of them, they have the perception of themselves and the reality that they're operating in. And based on that perception, they're able to communicate with each other. When we did that, we were able to actually start making this operation of the filter presses autonomous. But is that enough? No. We talked about advanced process control. So thickener advanced process control to stabilize the upstream, stabilizing the downstream. All of this goes hand to hand. So there is a graduation of different technologies fit for purpose, come together to build something bigger, to address a specific problem that we have. There is not always jumping to the end. And that's what we call autonomous operation of filter presses. I'll stop here with one message. Remember 102 hours? Bring it all the way to the 4 hours. Let's not lose the focus. There is so much money to be saved and to be gained, efficiencies to be developed by using right technologies and step by step increasing our autonomy to go toward autonomous operation. In Andritz, we're more than happy to talk to you. If you're interested, we have so many interactive demos that we can show you or success stories that we can share with you. Let's not lose the focus. Thank you.